Parallel computing with OpenMP. OpenMP stands for Open Multiprocessing. It's an API for writing multi-threaded applications. OpenMP has a set of compiler directives and library routines for parallel applications. It greatly simplifies writing multi-threaded code in Fortran, C, and C++. Just a few lines of additional code can make your applications parallel. OpenMP uses shared memory architecture. It assumes all code runs on a single server. A thread of execution is the smallest instruction that can be managed independently by an operating system. In parallel region, multiple threads are spawned and utilizes the cores on CPU. Another thing to note here is that only one thread exists in a serial region. OpenMP uses compiler directive #pragma to create parallel code. Source codes with a hash provide additional information to compiler. For example, #include add header file to source code. When a compiler uses an OpenMP options, it enables the #pragma and tries to parallelize the code that follows. And there are also some commands when you compile with OpenMP. When you compile with OpenMP, you need to add the argument -f OpenMP. You also need to include omp.h if you're using OpenMP functions. Here's an example of how you can use #pragma. The function starts with serial code. Then at the line #pragma omp parallel, a group of threads are spawned to create parallel region inside the bracket. And at the end of the bracket, the program goes back to serial region. I would also like to talk about the difference between thread and process. When a computer runs a program, your source code is loaded into RAM and process is started. A process is a collection of code, memory, data, and other resources. A process runs in a unique address space, so two processes cannot see each other's memory. On the other hand, a thread is a sequence of code that is executed inside the scope of the process. You can usually have multiple threads executing concurrently within the same process. Threads can be the memory of other threads within the same process. So one thread can write onto another thread variables. And so that the big difference is that a multiprocessing system has more than two processes, whereas multi-threading is a program executing technique that allows a single process to have multiple code segments. And that could sometimes utilize multiple CPUs.